go. Okay. If you're good with mole-to-mole stoichiometry, mass-to-mass stoichiometry, this is exactly the same stuff, except we have one more step to do. Um, very typically, we've been doing problems. Let me pick one out here from one of the old ideas here. We've been looking at problems like this, where you are told, you say, for example, if I have 2 sodium chloride plus fluorine gas, this is a single replacement reaction, and I end up getting 2 sodium fluoride solid and Cl2 gas. Now, if you look at your old worksheet, it says something like 14.5 grams of sodium chloride react with excess fluorine. Okay. And that word excess meant that in the problem we knew that we had 14.5 grams of sodium chloride, one of the reactants. The other reactant was in excess, which means that we had plenty. We had plenty. We had so much that, you don't have to worry about it in a calculation. But that's not real life sometimes. Sometimes it is. Sometimes we do have an excess reactant. Sometimes we don't. Sometimes you might see a question like this. Oh, and to let me finish this question, they would say something like, how many grams of NaF are produced? And in order for us to do a question like this, we learned that we didn't have to worry about the fluorine in the calculation. We said, well, I'm starting out with 14.5 grams of sodium chloride. I'm going to change that to moles, and then I'm going to do the mole ratio, which in this case happens to be a 2-to-2 ratio or a 1-to-1 ratio, and I'll get the moles of that and convert it to grams. So by now, you should be doing this in your sleep, I hope. But now we're going to say, hey, we don't know which one is excess. So the question would be something like this. As a matter of fact, I'm going to go back to that. I shouldn't have erased it. I'm going to go back to that very same question. It says, I'm going to go back and write the reaction again. Sodium chloride, the single replacement reaction, plus F2 gas to give 2 sodium chloride solid plus Cl2 gas. So it's the same reaction. See if I can get that better. But now they say, well, matter of fact, here, I'll give you the sheet so I don't have to write it up there. What?
This is the third problem.
Well, we're going to change it up a little bit. We're going to change it up. Oh, yes, you're right. It should be in that.
NaF.
Yeah. Pass these guys around. Make sure everybody gets one. I made a mistake. I'm glad that Landon caught me. Who caught me? Someone got me. That's fine. Yeah. So there's the reaction. But now let's take a look at the parameters of the problem. It says 24.5 grams of sodium chloride react with 41.3 grams of fluorine gas. Now, they want you to figure out which is the limiting reactant and which is the excess reactant. Now, you might be tempted to say, well, I have more grams of fluorine here, so maybe that's the excess one. We can't do that. We have to say, well, I have to do this calculation. And the way I like to teach limiting reactant, other people teach it a little bit differently. What I like to do is I like to um, do the calculation twice. Once based upon one of the reactants, and just do it a second time based upon the other reactant to see which gives us the smaller quantity of product. And the one that gives us the smaller quantity of product by necessity is the limiting reactant. That's the one that runs out first. Because remember, you can only make as much product as you have reacted to make that product. I always used to talk about sandwiches, like if, again, if I have 17 loaves of bread and only, you know, 10 slices of lunch meat, I'm going to have a lot more bread left over. Unless you just make a sandwich with a lot of bread, but we're not doing that. We have a very specific formula here, a very specific recipe. Um, so when I look at these problems, I want you to read the entire problem before you start doing calculations. So this problem says, A, what is the limiting reactant? Justify your answer. B, how many grams of chlorine gas are produced? So the way I do these problems is I say, well, let's figure out which product I want to concentrate on. In this case, I want to concentrate on chlorine. So I set up the problem twice. Once based upon 24.5 grams of sodium chloride. I do it based on that, and then I do it based upon 41.3 grams of fluorine. Do the whole calculation, see how much chlorine I can make. Do the whole calculation, see how much chlorine I can make. And the one that gives you the smaller amount of chlorine, that's going to be the limiting reactant. That's all there is to it. It's very straightforward. So let's go ahead and plug and chug and see what we can come up with. We're pretty good at doing these problems by now, I hope. So again, sodium chloride, you have to change it to moles. And then we've got 1 mole of NaCl is 58 grams of NaCl. You get to know that after a while. And it is 1 mole of chlorine to 2 moles of sodium chloride. 1 mole of Cl2 to 2 moles of NaCl. And it's about 71 grams, if we round, 70.8 grams of Cl2 per mole of Cl2. So running out of board space here, but that's okay. So let's go ahead. We have a little less than half a mole here. And divide by 2, multiply by 70.8. And I end up making, and you could double check me on this, I end up making about 15 grams of chlorine here, 14.95, so 15, 3 sig figs grams of Cl2. I make that much chlorine based upon 24.5 grams of sodium chloride. Let's take a look here. Let's do it again. Let's see which one gives me the smallest amount of chlorine. Well, I've got 41.3 grams of fluorine, and it's F2, so that's about 38 grams of fluorine per 1 mole of fluorine. And it just so happens that fluorine and chlorine are in a 1-to-1 molar ratio. 1 mole chlorine to 1 mole fluorine. And then again, we've got 70.8 grams of chlorine for every 1 mole of chlorine. And I can kind of already tell that, we're going to get more, because that's more than 1 mole. But let's do it anyway. 41.3 divided by 38. And you end up, if you had that much fluorine, and you're just ignoring this, you could potentially make 76.9 grams of chlorine. So you look at the two things. You say, I can only make as much as the limiting reactant allows me to make. So in this case, sodium chloride is the limiting reactant, because based upon that much sodium chloride, I can make only 15 grams of chlorine. Now, if I was going to base it upon the fluorine, I can make 76 grams. But we can't make 76 grams because we're going to run out of this stuff first. So sodium chloride is the limiting reactant, and then fluorine is excess. It just so happens that the last problem we had, the fluorine was excess as well. It's not always going to be the case. But there's really nothing to it. You do the problem twice, and you say, which one gives me the smallest amount? And that's about the extent of it. Now, what's kind of interesting is we could use stoichiometry here to say, well, how much of the excess one is left over? Because remember, stoichiometry allows us to compare the two reactants as well. So you could say, well, I've got 24.5 grams of sodium chloride and 41.3 grams of fluorine, and do the stoichiometry based on that and figure out how much of the excess reactant is used up and how much is left over. So it's pretty straightforward. Again, to summarize, read the entire problem, because if you go ahead and you say, well, I want to just compare these to one of the products, chances are in one of the parts of the question, they're going to ask you about the product of choice anyway. So you might as well base it upon that. You already have your answer done. Does that make sense? It's nothing outrageous. So why don't you try? Let's see here. Try number two. I do want to mention something before we go into number two, a concept called percent yield. We talked about that in lab a little bit. But before we do problem two, they ask you about percent yield. And let me mention that. I mentioned it, like I said, when we were talking about our experiment. And it's a real easy thing to think about. So let's say you go into the kitchen, and what did you call those things? What did you call the pierogi? Pierdos? Well, let's say Pierdo. Let's say you're going to make some pierogi or pierogies, and the recipe says that you're going to, if you follow everything right, you should make a dozen, right? But let's say Colonel's back there, and he, I don't know, maybe he drops a couple on the floor before he gets them over the frying pan, and maybe Cody didn't see it and steps on them, crunch, crunch, right? So you only have 10. So your percent yield would just be your actual amount divided by your predicted amount times 100. Okay. So the same thing with chemistry. Percent yield, you get a theoretical amount from your calculations. So your stoichiometry gives you the theoretical amount, and then you actually get an experimental amount when you go into a lab times 100, and that will give you your percent yield. So remember when we did that experiment with the salt, maybe you predict that you should get 0.6 grams, you maybe only got 0.4 grams. So that's percent yield. Very easy to do. So go ahead, work on question two, and let's see what we do with it.